This is another lesson taken from coding robots. It discusses the relationship between the wheel size and the distance covered by the robot with each turn of the wheel. When a wheel completes a full circle, it actually covers a distance equal to its circumference. With real robots, this is an engaging activity in itself. Asking students to prove or disprove this theorem, they'll need to set up an experiment, collect data, analyze it, and, looking at the data, reach a conclusion. We will relate to this as an axiom. The wheels of the LEGO Mindstorms EV3 robot are exactly 5.6 centimeters in diameter. This means, applying the formula pi times d, that the wheel circumference is 17.6 centimeters. This means, according to our theorem, that the robot will traverse 17.6 centimeters for each one complete rotation of its wheels. That, of course, applies to driving forward, both wheels at the same speed. Notice how we are constructing knowledge while using math, science, and engineering. This is interdisciplinary STEM. Moving on, taking into consideration a circle has 360 degrees, we can find out the ratio between the degrees of the wheel and the distance it covered in centimeters. This degrees to centimeters ratio will later on help us control the distance the robot covers using encoders. Encoders are sensors installed on the motor itself that measure its rotation in degrees. Encoders can tell us how many degrees the motor has turned. Dividing 360 by 17.6 centimeters, which is the wheel circumference, gives us a ratio of 20.45 degrees per centimeter. This means that while moving forward, the robot will cover a distance of 1 centimeter for every 20.45 degrees the robot has turned. Understanding this relationship requires practice, which is easy to get using CoderZ. Before putting this newfound knowledge into good use, let's go back into CoderZ and move on to the next navigation mission.